I have my building and I have a number of selections in this building which are stored in a group. I'm currently going to use this group to add doors to the building. I could rename this group to doors, but that would actually break my script, so I'm not going to do that yet. We can organize that kind of functionality later. Before that, I want to explore how I can work with these groups. I want a split node and I want a blast node. I'll start with the blast node and I'll connect this to my color. In the blast node, I'll delete the floors. In this case, I'll delete both the interior and the exterior floors. This will give us the selection which will only contain the walls. The walls can be connected to my split node, and here I'll split these based off my test group. I'll invert the selection so that my first input is defining the walls. I will want to modify all of the primitives for these walls, and I'm going to extrude these within a for loop, and this will be a for each primitive loop. I will have one of these loops for each of the outputs of my split node. So I'll duplicate the loop and I'll connect it to the second output of the split node. I'm going to begin by extruding all of the walls outwards. This will allow me to maintain the ceilings as interior ceilings. This will mean that I do not have to resize the ceilings. We can approach the extrusion either way, as we'll have to compensate no matter which way we do this. But I will start with an outward extrusion. I'll do this with the poly extrude node. I can add this node to my for loop. I'll increase the distance, and my walls will extrude, but currently I'm extruding every single primitive individually, and this is not what I want. So once again, I'm going to update the attributes in my for loop, and I'll loop over every floor by using the piece attribute, and this will be set to floor number. I'll connect a normal node after my extrude node, and this should clean up some of the lighting issues. There's a lot of geometry which we are producing for these walls which we may not need to keep. We have the sides extruded. These can be useful, but we won't always need them. One thing that I do want to keep is the back-facing surfaces. I definitely want to keep the front and the back of the wall. I do want to generate the groups for these walls, so I'll activate the groups for both the front and the back-facing walls. There are other groups which I could activate, but I'll leave those for the moment. I'll then get a group node to create a custom group. I'm going to use this to delete polygons which are facing upwards, so I'll call this delete group up. I'll give this group the name delete. I'll delete this group after our for loop, so I'll get a group delete node and I'll attach this after the for loop. I can remove the delete group as I will not need it after this. I'll now set up this delete group. I'll disable the base group and I'll activate keep by normals. I want the direction to be facing upwards, so this will be 0 in X, 1 in Y, and 0 in Z. I'll set the spread angle to 0. As I said, I may want to keep these faces, but for the moment I'm going to set this up so that I can delete them. I'll duplicate this group, and this will be called delete groups down. And these groups will be followed by a blast node. I'll set the vector to be negative in Y, and instead of replacing the group, I'll set this to union with existing. In the blast node, I can now specify the delete group, and I'll delete the primitives. So this will delete extra faces, although we do not necessarily need to do this. I can make this optional by getting a switch node, and I'll connect this after the blast node. I'll rename this node, and this will now be switch clean geometry. By default, I'll delete this geometry. The geometry at the top and the bottom of our walls is the most important to delete. I'll illustrate this with the fuse node. If we bypass deleting this geometry, we can end up with non-manifold geometry. This means that we'll have geometry within our walls. This geometry is not visible, but it can cause problems with game engines. It can cause problems with deformation. It can also cause problems with simulations. And where possible, we'll prefer to have continuous geometry without invisible geometry which is not needed. This kind of problem can be fixed with other nodes. For example, the clean node. The clean node will allow us to remove non-manifold topology. So this will give us some basic walls. The output for the side of the network can then be merged with the side of the network for the doors. We've now got our isolated faces. For the moment, I'm going to add doors to these. This is going to be very perfunctory, and it is not going to take into account the style of the building, but it will allow us to set up some base functionality. This will be very similar to our walls. We'll set up an extrude node. I want to output both the front and the back, and then I'll increase the extrude distance. After I've extruded the walls, I'll clean up the geometry again. This gives us some slightly different extrusion on the walls, but what we really need here is our door geometry. I'll need to create this geometry. To do this, I'm going to get an attribute wrangle node. I'll connect my for loop to the second input of the attribute wrangle node, and then I'm going to create a grid node. I'll give this a size of about 0.86 by 2. This is approximately the size of a door, although door sizes will vary. I'll update the orientation for this, and this will lie along the XY plane. I then want to move this so that the base of this door is at 0 in the Y-axis. I'll modify the Y value for the center. This will be set by our size in Y, and I'll divide this by 2, and I'll do this by multiplying the size in Y by 0.5. We now have a template for our door. This is placed at the center of the world, and the front of the door is facing down our Z-axis. Next, we're going to interact on the walls which we've marked as doors. These are going to be the primitives which we've specified within our group. We will want to find the center of these, but we'll also want the center to be aligned along the base of these primitives. I'm going to calculate this from within my attribute wrangle node. I'll begin by getting the center of these primitives, and I'll store this value in a vector. I'll give this the variable name VC. This will be set using the getBoundingBoxCenter function. I'm going to get my bounding box from the second input, so this will be input 1. I do not want to retain the original geometry, so I could delete the geometry, but if I get my geometry from input 1, I will not have to worry about doing this, as I will only be dealing with the data. I'll duplicate this line, and I'll rename the variable to VM. This is going to be my minimum value for the bounding box. I'll get this using the getBoxMin function, and the geometry will also come from input 1. I can now use this information to add a point. This will be done using the addPoint function. This will be added to our current geometry. So this will be from input 0. Since nothing is connected to this node, this means that we'll be generating the geometry. I'll then need a position for this point, and this will be set with a vector. I'll create this using the set function. I'll get our x value from the center. So this will be VC, and the index will be 0. The y value will be the minimum height. This will be VM. This will be my y value, and we'll have an index of 1. For my z value, I'll also get the center, and this will be VC with an index of 2. So we're getting our x and our z value from the center, and we're getting our y value from the minimum. This should give us a point at the center of the base of the primitive. I'm not seeing anything. This can sometimes be because of the set function, as the set function does not always work correctly when used as an argument. So I can separate this, and I can store this in a variable. This will be a vector variable, and I'll call this point, and this will be set with my set function. This can then be used in the addPoint function. This, however, does not change anything in this case. We're currently generating the points with no geometry, and because of that we have no points. So running over the points will not do anything, because there are no points to run over. So I can change this by making sure that this will run once, and I'll do this by changing the points to detail. We should now have a point at the bottom of our primitive. If I plug the output for this attribute wrangle node into the for loop, we should now be generating points for each primitive within our group. I can now do this to place my door geometry. This will be done using a copy to points node. The geometry that I'm copying will be the grid, and this will be connected to the first input, and the attribute wrangle node will be connected to the second input of the copy to points node. I do need to update the grid node. I should set the rows and columns to 2, as we only really need 4 points for this geometry. I can now use this geometry in a number of ways. The first thing that I can do is I can get a boolean. This will be connected to the main branch of the for loop, and the second input will be set by my copy to points node. There are a number of ways in which we can perform the boolean, but for the moment I'll use a union. When I look at my extrusion, I should now see a hole in my wall, and this will provide me with a potential doorway. This geometry may not be sufficient for all needs. Part of the setup will obviously not work well for certain details, so we'll need to consider adjusting the scale of the primitives in the future. However, the final details are not that important at the moment. What is more important is having geometry where I can test interactions. The next thing that I may want to do is add the door to this structure, and this structure will change shape, and we want to be able to move our door relative to the structure. I do not necessarily want to have this placed at the back of the structure, so I cannot just place this. I will also want some control. I will need to start by merging this with the geometry, and this will be done with the merge node. I'll do this just before my for loop ends. I can also add normals to the door, as it currently does not have correct normals. I want to be able to adjust the point position before I merge this. I'll get an attribute wrangle node, and I'll connect this after the normal node. I'm going to update the point position, and I'm going to base this off the current point position, and I'm going to add a vector to this. We're going to get this by multiplying a normal by a float value. I'm going to create this value using the chf function. I'll give this a name, and the name will be distance. I can then generate this parameter, and I should now be able to shift this door. The door is currently facing the wrong direction. I'll fix this with the reverse node. I now have a basic building, and I've given myself depth on the walls. I've also added door geometry. I can now connect this for loop to our network, and we'll now have a problem. When I exit this node, it is working properly, but if I try to change my selection for the viewer state, our viewer state will break, and we'll no longer get the correct geometry selected for our walls and doors. This is something which we should be aware of when dealing with geometry for viewer states. The viewer state geometry is very often defined by the output for the geometry. This is not necessarily a problem, and in some ways we can see this as an advantage, in that this does force me to be more flexible in my approach. The easiest way to solve this will be to move the entirety of the logic which I've just created out of this network. So now I'll separate the creation of the building structure from the creation of the details of that structure. The first HDA we've created will now serve purely as a structure, and we can use this to create data to generate our building with. We can then use that data through a number of separate networks. This will also make our network more easy to integrate with PDGs, which can give us more flexibility in terms of pipeline. So I'll select items within our base network, and this information will be used in later networks. So I've got the basic building, I've added walls to it, I've added some basic doors, and I can add depth to these doors. Though there are still a lot of issues which I'll need to fix here, but this will give me my basic door setup, and I can now continue to expand on the base structure of the building.